Hey, it's Mr. Veve again. Bet you're expecting somebody else. Too bad. It's Unit 2, Part 2. This is now Module 5, Electromagnetic Spectrum with Frequency and Wavelength. So let's look at the definitions we have for frequency and wavelength. First of all, wavelength is the distance from one peak to another, and frequency is the number of wavelengths that pass in 1 second. So if you're thinking about a wave in terms of peaks and troughs, then you can really understand the idea between wavelength and frequency. So the electromagnetic spectrum is actually a range of all the possible wave frequency in this electromagnetic radiation. These waves are created by the systematic interactions of electric and magnetic fields. That's why it's called the electromagnetic spectrum. The general term for all electromagnetic radiation is light. And the range of the EM spectrum is from very low frequency, known as radio waves, and you go all the way up to very, very high frequency, which is gamma radiation. So the visible spectrum of light is in the center portion of the electromagnetic spectrum. That is the light that we can actually see. And the electromagnetic spectrum travels at the same speed in a vacuum. This is known as the speed of light. That's equal to 3 times 10 to the 8th meters per second. So here's a picture of the actual electromagnetic spectrum, and you can see shorter wavelength, higher frequency all the way to the left, and then longer wavelength, lower frequency all the way to the right. So the high energy stuff on this chart here is all the way to the left. The low energy stuff is all the way to the right, and you can see the visible spectrum is nestled right there in the middle. So now we're looking at speed of light and frequency. So since the speed of all electromagnetic radiation is the same, there's a mathematical relationship that we can look at between frequency and wavelength and the speed of light. So we know that all waves travel at a speed that is equal to the product of frequency and wavelength. So frequency times wavelength equals speed. And so we can represent that with C equals F times lambda. Now F is frequency, lambda is wavelength, C represents the speed of light here. And we know that the speed of electromagnetic radiation is fixed at 3 times 10 to the 8th meters per second. So we can rewrite that equation as 3 times 10 to the 8th meters per second equals frequency times wavelength, because the speed never changes. So therefore we can look at that as speed of light equals frequency times wavelength. And since frequency and wavelength are multiplied together, we know that they have an inverse relationship. When frequency goes up, wavelength goes down. And as wavelength goes up, frequency goes down. So an example here is if frequency doubles, wavelength is cut in half. If wavelength doubles, frequency is cut in half. So it's that sort of relationship. So here are a couple of examples of calculations, and remember, as frequency goes up, wavelength goes down, and vice versa. So if the wavelength of a radio wave is 15 meters, what is the frequency? Well, we plug it into the equation here. We know speed is 3 times 10 to the 8th meters per second. We're going to say that is equal to frequency times the wavelength, which is 15 meters here. Okay, so we need to get our variable by itself. So we need to divide both sides by 15 meters. So frequency is equal to 3 times 10 to the 8th divided by 15. And that will give us the frequency, which is 2 times 10 to the 7th. And the unit for frequency that we use is hertz. Another example here is if the frequency of gamma radiation is 6.25 times 10 to the 22nd hertz. What is its wavelength? Okay, well, we already know that 3 times 10 to the 8th meters per second is our speed. That stays the same. And that is equal to frequency times wavelength. The problem here gives us the frequency at 6.25 times 10 to the 22nd. And we plug that in where the frequency goes. And we leave lambda, which is wavelength, blank. So we need to solve for lambda by dividing both sides by 6.25 times 10 to the 22nd. Okay, lambda is now by itself, and we do 3 times 10 to the 8th divided by 6.25 times 10 to the 22nd. And we get our wavelength, which is equal to 4.80 times 10 to the negative 15th meters. Now make sure you try these calculations. You hit pause and try these calculations just to make sure you can get the same numbers that I've gotten. If not, make sure to write it down in your visa to make sure we can understand it and help you out with it later on. Here is the only key term that you have for this module, and we'll see you in the next module.